Welcome everyone. I'm excited to welcome you to today's presentation. Today, we'll be exploring BORCELLE and gravity, two innovative solutions that are shaping the future. Over the next few minutes, we'll take a closer look at our services, our story, and what makes us unique. So let's get started and discover how we can help you achieve your goals. Gravity is all around us. It's an omnipresent force that influences every physical interaction we experience. From the simple act of walking on the ground to the movement of fluids in our bodies, gravity is constantly at work. Despite being one of the weakest of the fundamental forces, it plays an essential role in maintaining cosmic order. It's what keeps galaxies, stars, and planets forming and in motion, ensuring the universe remains structured. Now, when we talk about gravity as an invisible force that governs motion, we mean it's fundamental to how objects move both on Earth and in space. It's the force that pulls two objects toward each other, and its strength depends on their masses and how far apart they are. For example, it's what keeps planets in orbit around the sun, governs the rise and fall of tides, and shapes the structure of the universe itself. Understanding gravity helps us grasp the bigger picture of how everything in the cosmos is interconnected through this unseen but powerful force. Let's talk about Newton's apple and how it marked the birth of a groundbreaking theory. For centuries, people have been curious about gravity, that invisible force that pulls objects toward each other. Ancient civilizations noticed its effects, like objects falling or planets orbiting, but they didn't really understand what was happening. The most famous story, of course, is about Sir Isaac Newton in the 17th century. Legend has it that an apple fell from a tree, and this simple event sparked his curiosity. That moment, whether fully true or not, symbolizes the beginning of serious scientific thinking about gravity. Newton went on to develop his laws of gravitation, which help us explain how planets move, how objects fall, and how celestial bodies interact. This story illustrates how observations, like an apple dropping, can lead to profound scientific discoveries. It's a great example of how curiosity and simple questions can lead to the development of theories that change our understanding of the universe. And that's what this presentation is all about, exploring the forces that shape our cosmos, starting with this pivotal moment in scientific history. Let's take a closer look at what Newton's law of universal gravitation really means. Essentially, Newton proposed that every object in the universe attracts every other object with a force. Now, this force isn't random. It's actually proportional to the masses of the objects involved. So, the more massive the objects, the stronger the gravitational pull between them. But there's more to it. The force is also inversely proportional to the square of the distance between these objects. This means that as objects move farther apart, the gravitational force decreases quite rapidly. This relationship helps us understand everything from how planets orbit the sun to why objects fall to the ground here on Earth. It's a fundamental principle that laid the groundwork for physics as we know it today. And interestingly, this law remained the dominant explanation for gravity until Einstein introduced his theories in the 20th century, which refined our understanding even further. So, Newton's law is really the cornerstone that connects to the broader theme of understanding the universe through mathematics. Einstein revolutionized our understanding of gravity by proposing that it's not just a force acting at a distance, but actually a curvature of spacetime caused by mass. In his groundbreaking 1915 general theory of relativity, he demonstrated how massive objects like stars and planets bend the fabric of spacetime around them. This curvature then influences how other objects move, explaining phenomena that Newton's theory couldn't fully account for. What's truly fascinating is that this theory allows us to predict effects like gravitational time dilation, where time runs slower near massive bodies. It also gives us the concept of black holes, regions where spacetime becomes so curved that nothing can escape, and helps us understand the expansion of the universe itself. All of these insights tie back to the idea that gravity is a geometric property of spacetime, transforming how we see the universe and our place within it. Let's start by looking at the role gravity plays in atmospheric retention. Gravity is what keeps Earth's atmosphere securely in place. Without it, essential gases like oxygen and nitrogen would drift away into space. This retention is crucial because it creates the breathable environment we depend on for life. Moving on to tides, gravity from the moon and the sun exerts a pull on our oceans. This gravitational force causes the regular rise and fall of ocean levels, known as tides. These tides are more than just a daily rhythm. They influence marine ecosystems and shape coastal environments, impacting everything from marine life to human activities along the shoreline. Finally, let's talk about acceleration due to gravity. On Earth, gravity causes objects to accelerate downward at about 9.8 meters per second squared. This acceleration determines how fast objects fall and plays a fundamental role in the physics of motion around us. Understanding this helps us grasp everything from everyday movements to complex scientific phenomena. Connecting all these points back to our overall theme, gravity isn't just a force acting on objects. It's a key player in shaping our environment, supporting life, and influencing natural processes around us. Now, let's explore how gravity influences space travel. Spacecraft need an enormous amount of energy to break free from Earth's gravity and to travel between different celestial bodies. This is one of the biggest challenges in space exploration. Moving on, gravity also plays a vital role in the formation of celestial bodies like stars and planets. It pulls matter together in space, allowing these massive objects to come together and form over time. Without gravity, these processes simply wouldn't happen. Next, let's consider how gravity keeps planets and moons in their stable orbits. The gravitational attraction between these bodies and larger celestial objects, like the Sun or Earth, ensures they stay in consistent paths around each other. This balance is what maintains the structure of our solar system. Now, when astronauts are in orbit around Earth, they experience what we call microgravity. This means they float freely because they are in a continuous state of free fall around the planet. It's a fascinating environment that significantly affects the human body and how we conduct experiments in space. Understanding these effects of gravity is essential as we continue to develop space travel technologies and explore further into the cosmos. Black holes are some of the most fascinating and extreme objects in the universe. They are regions where gravity becomes so intense that even light cannot escape, which is why they appear black. These incredible objects form from the remnants of massive stars that have exhausted their fuel and collapsed under their own gravity. As they collapse, they distort spacetime itself, creating gravitational effects that push the boundaries of our current understanding of physics. Their immense gravity pulls in the surrounding matter, and as this matter gets pulled closer, it heats up to extremely high temperatures. This process causes the emission of powerful radiation, which scientists can detect and study to learn more about these mysterious objects. Understanding black holes and their extreme gravity helps us explore the fundamental laws of the universe and the limits of physics itself. Let's explore the fascinating role of gravity in shaping our universe. First, we have the star life cycle. Gravity is the key driver here, guiding a star's journey from its formation to its ultimate fate. Depending on its mass and other factors, gravity determines whether a star becomes a white dwarf, a neutron star, or even a black hole. It's incredible to think how this force influences so much of a star's life. Next, we look at cosmic expansion. While gravity pulls objects together, there's also dark energy working in the background. This mysterious force interacts with gravity, and together they influence how the universe is expanding at an accelerating rate. It's a delicate balance that's fundamental to our understanding of the cosmos. Finally, gravity is essential in galaxy formation. It pulls together stars and gas, allowing galaxies to form and evolve over billions of years. Without gravity, the large-scale structure of the universe simply wouldn't exist. It's the invisible architect behind the grand design we observe on a cosmic scale. All of these points highlight how gravity is not just a force, but a fundamental architect of the universe, shaping everything from individual stars to the vast cosmic web itself. Now, let's explore some everyday applications of gravity. and see how it influences our daily lives in more ways than we might realize. First, gravity is what keeps us firmly anchored to the ground, preventing us from floating off into space. It's also the reason water flows downward, shaping everything from rivers to ocean currents. And when it comes to energy, gravity plays a crucial role in hydroelectric plants, where water's movement generates electricity. Engineers, of course, have to consider gravitational forces when designing stable buildings and bridges to ensure safety and durability. Scientists leverage the understanding of gravity in various fields, from medical research to space exploration. For example, gravity influences how we develop medical technologies, and in space, understanding gravity helps us plan missions beyond Earth. Even in timekeeping, atomic clocks are affected by gravitational time dilation, a fascinating effect predicted by Einstein, which is essential for the accuracy of GPS systems. So, as we see, gravity isn't just a force pulling us down. It's a fundamental part of how our world functions and advances. Stay curious and explore. I encourage you all to keep that sense of curiosity alive as we conclude. Remember, exploring new ideas and opportunities is key to growth. On this slide, you'll see our main sections: services, contact, blog, about us, and home. These are pathways for you to connect more deeply with what we offer and learn more about us. Of course, I want to thank you for your time and engagement today. Your curiosity and willingness to explore are what drive innovation and progress. So, I invite you to stay curious and continue exploring beyond this presentation. Keep that spirit alive as you move forward. Thank you.